Hello! Today we want to talk about a topic called progression. First of all, progression can be divided into arithmetic progression and geometric progression, but we will focus on geometric progression. It is a sequence that has common ratio of two conservative terms. For example, this sequence is a geometric progression because it has common ratio of 3. Here are the list of formulas of geometric progression that you need to know. Firstly, we have common ratio. We represent it as letter R. Secondly, we have the formula to find the nth term. A represents the first term of the sequence. Third, we have the sum of the first nth term formula. It is divided into two formulas depending on the value of common ratio. And lastly, we have formula to find sum to infinity. These are the examples of questions. First one, find the first term A and the common ratio R for the following geometric progression. From this sequence, we can identify the first term A, which is -3. To find the common ratio R, we need to divide the second term with the first term, and we will get -2 as the answer. The second question, we need to find the nth term, Tn, for the following geometric progression. In this question, we are given the value of n, which is 10. To answer this question, we need to find the value of first term and the common ratio. After that, substitute the values obtained into the nth term formula.
So today I'll be explaining the question chosen. So as that is cut into n parts, the length of each part increases, forming a geometric progression. It is given that the length of the sixth part of the track is 9 times the length of the fourth part of the track. So question A, calculate the common ratio. So we all know that the common ratio is represented as a symbol R. So therefore in the question it says that the length of the sixth part is 9 times longer. And the length of the fourth part is 9 times longer than the sixth part. So putting it in a formula view, we can see that T6 equals to 9 times T4. So changing it into a geometric progression, we all know that Tn, finding the term for in a geometric progression, equals to A times R to the power of n minus 1. So putting it, changing it into AR, it will be AR to the power of 5 equals to 9 times AR to the power of 3. So moving AR to the power of 3 to the left side of the equation, it will be AR to the power of 5 over AR to the power of 3 equals to 9. So we can cut down on the A, which is the first value, and the R5 over R3 will equal to R square, and R square equals to 9. We can cut out the square and move it into square root to the 9, so to the right hand side of the equation. So we can get R equals to 3. So that is the first answer for the question A. So next is moving on to the second question. If the total length of the track is 1456 centimeters and the length of the first part of the track is 4 centimeters, calculate the value of n. So the value of n, okay, so we can see that the sum is 1456 centimeters. So that will be the Sn, the sum. So the formula for sum of total is A bracket R to the power of n minus 1 over R minus 1. So putting all the values in the formula, we can get 4 times 3 to the power of n minus 1 over 3 minus 1 equals to 1456. So 3 minus 1, 4, bringing it to the right hand side, and 2 bringing it to the right hand side. You can see that the formula is now 3 to the power of n minus 1 equals to 2 times 1456 over 4. And changing it 1 to the power of 2 times it, we can get 3 to the power of n minus 1 equals to 728. So bringing the 1, adding it onto the right hand side, we can get 3n equals to 729. So 729 equals to 3 to the power of 6. So converting it, we can get that n is equals to 6. So the second question, calculate the length in cm of the last part of the track. So we know the last part of the track is the sixth part. So the last part is T6. So changing it in the formula, AR to the power of n minus 1, we'll get T6 equals to AR to the power of 5. So putting the first part in and 3 to the common ratio 3. So it will become 4 times 3 to the power of 5. That will get 972 centimeters. So that is all the answers for question 3.
Example 1. A healthy product company has planned a marketing strategy. Each member has to promote the company products by getting 2 downlines. So here, what we can relate with the geometric progression. As we all know, geometric progression is a sequence of number where each term is obtained by multiplying a constant with the previous term. So in here, we can clearly see that it's all divided by 2, which is constant. So that's how geometric progression related to our daily life.
Let's move on to second example. Population growth. Each couple do not decide to have another kid based on current population. So population growth each year is geometric.
Last but not least, the next example is each radioactive atom independently disintegrates, which means it will have fixed decay rate. In other words, that is why there is half-life of a radioactive element. In a fixed amount of time, it becomes half.